This video we are going to talk about solving equations that involve E or Ln. And there are a couple strategies that I want to teach you. It depends on the setup of the equation. For example, this one looks familiar compared to our previous examples. When the base are the same, then we could just forget about the base and just focus on the index on both sides. So for example, this one would just give this. Now we have a quadratic. Now for this one, it's not easy to make the bases on both sides to be the same. This time we could apply ln or log on both sides, and then the index would just come down. But now we're facing a dilemma. Do we apply ln on both sides so that for the left hand side would just become 3x minus 2, but then on the right hand side you still have some sort of ln, right? Or do I put log base 4 so that this one, my 4 goes away, and this one I still have some messy things. But for now, let's go for ln, because if you put log base 4, this looks much more complicated, right? So we use ln. And so when I do that, all my variables are back down. Okay, so this is good. Now it was a good decision because now we are left with simple x. We could just combine them, make x the subject. So then I could factorize out the x to just have just one single x. And so x equals to 1.24. Now let's consider this question. If we apply ln on both sides, it looks okay. However, what do you do with the left hand side? It leads you to nowhere because you cannot break this up. You could break this up into this, and this part actually looks pretty good because this cancels out and gives 2x. But again, this part is not going anywhere. So we may have to find some other choice. So here's another strategy. Look for quadratic. Because I see this is e to the power of 4x and this is e to the power of 2x. And this is actually square of this, right? So if you treat this as the basic unit and this as the square of this, maybe we could find us a good solution, right? So now we have a quadratic and see what it gives us. Or maybe you could treat this as y, that y equals to e to the power of 2x. And so that gives us two paths right there. And then we continue and we break this down into the smallest prime number, that is 2, and we move the index to the front. And so x equals to negative ln 2 or 0. Now another type of question involves ln to begin with. The strategy is to combine the many ln's into one, or combine the many e's into one. So for example, if I move this 2 back in there, I could actually put this together, right? I could do this. Okay, but if you still remember, this works, but this is not going anywhere. It's the dead end, okay? Don't mix it up. So then I actually apply e on both sides. So this e and ln cancels out. I have e to the power of 0, but this actually equals to 1. And then I simplify it to get a simple quadratic, and I could solve the answer. But this part is very, very important, and this is something that we have talked before. Why do we have to reject this negative 2? You always have to check your answers. If I put negative 2 in here, this is ln 1, which is okay. But if you put negative 2 in here, that gives us ln of negative 1. Do you still remember, for anything that goes inside after the ln has to always greater than 0. You still remember this is the graph of ln x. It always stays on the right hand side of the y-axis. It's not even touching the y-axis. Okay, so it's always greater than 0 for the x as the domain. Okay, that's why it has to be rejected. Now, if we look at these strategies, actually this one somewhat also applies to this question. Okay, but now we're not looking at the base. We are looking at what goes into the ln. For example, if I move this to the right hand side, I actually get ln this equals to ln this, right? So just like this strategy, I could actually disregard the ln because I could apply e on both sides and we get the same thing here. And what follows is exactly what we did. So it still works. Okay, but I still want you to remember these strategies so that you can apply some of these when the situation fits. Okay, but remember, check your answers at the end.